Welcome to Lecture 7, Structural Modeling. It's about modeling classes. This figure shows the sequence of the structural modeling among the development phases. We have done the behavioral modeling and obtained precisely defined use cases in previous lectures. In this lecture, we further process those use cases to identify the smaller building blocks for conceptual modeling. This lecture covers topics. The first topic is the essentials of structural modeling for the system. The building blocks of structural modeling are the classes or entities. You'll understand the features of structural modeling in terms of the view, the scope, and the scale. You'll find the answers from the lecture notes and the textbook. The second topic is about basic OO concepts in the context of structural modeling. You are familiar with those concepts already, such as classes, objects, attributes, operations, encapsulation, and interfaces. The third topic is the main task for discovering class candidates. You will find out how to identify the classes with their responsibilities. The instructions are given in the lecture notes. The first topic is for elaborating and defining classes. This means that you will identify the class attributes, operations, and the collaborators of a class. You will understand the different relationships among classes, such as aggregation, composition, and generalization. At the end, you will draw those different types of class diagrams. This figure depicts the process of developing structural modeling. Please notice that building blocks behavior modeling are use cases. We've developed and refined use cases in previous steps. Next step is to discover the class candidates and their relationships. Classes are the basic building blocks of object-oriented modeling. Those conceptual classes are structured to support the system's behavior for conceptual modeling. The final structural modeling represents a view of entity classes and their interrelationships within a given scope. To discover business objects, we must start by managing the flow of use cases. Use cases are necessary for starting the process of discovery. This is the first step for finding class candidates. You pass templates of use case, you search for nouns as grammatical objects and hidden grammatical objects for potential class candidates. You mark them by underlines. Actors is not a class if it's outside of system in all use cases. This figure presents the overall process of finding class candidates. Please notice here, we'll use text templates of use cases for manings. Based on the templates of use cases, you'll identify the grammatical objects and objects hidden in verbs as potential classes. The previous slide shows this step. Next, you will define classes in detail for outlining their responsibilities. The responsibilities are what the class can do and what it knows. In other words, its operations and associated attributes defined in the class. This table is to fully define a class and its responsibilities in detail. Each class has a number of obligations, such as its attributes to describe itself, and its operations for what the class can do. Each class can collaborate with other classes. For example, this patient class knows patient data, the name, birthday, address, and the insurance, and so on. A collaborator is a class that carries out the responsibilities of another class. Here, the country, address, phone, insurance policy, and credit card are collaborators for a patient to describe its attributes. A class delegates its responsibilities to other class that's called collaboration. To elaborate class responsibilities, the operations are defined to outline what the class can do. The collaborators of patient for its operations are classes of appointment, patient billing, and next kin. Those classes are defined to delegate tasks of a current class patient that defines the relationship of the classes. After you have elaborated classes and identified their collaborators, the relationships are defined. You have built a conceptual model of the system in the defined scope. The conceptual model captures important concepts and relationships in the business domain. Those concepts are represented by classes, while relationships are represented by associations with other collaborators. Next step, you can create class diagrams by ULM to represent groups of related classes and associations. Class diagram shows a set of classes and their interrelationships. There are many types of class diagrams. Each class diagram has got a viewpoint. The first important class diagram is to show a class viewpoint for its responsibilities, relationship with its collaborators in a cooperative context. This type of class diagram shows one central class with its associated collaborator classes. The other type of class diagram provides a compositional context, such as the collection type of collaborators, aggregation or compositional relationship, generalization and specialization associations. You should be able to draw all those different types of class diagrams to visualize the structural modeling. Here shows you one example of a class diagram for patient class responsibilities and its associations. It's for the cooperative context viewpoint of a class. It shows the detailed attributes and operations of a patient class with its associated collaborators. The detailed information for collaborators are ignored due to the space limitation. This class diagram shows the viewpoint for compositional context. The point of view is for the collection type of collaborators who are member attributes of a patient class. It describes all collaborators with their associations and multiplicity. It ignores the detailed information for patient class. The class entertainment system shows an aggregation relationship with a sound system and a television site. Those two classes can be independent for entertainment system class. The hollow diamond represents the aggregation notation. The solid diamond represents the composition notation. Here is another example for aggregation class. The country is an aggregation class since it's independent of a patient. Other classes are dependent to patient. For example, the treatment class doesn't exist if there is no patient. This class diagram shows the generalization and the specialization relationship between classes. It's also called superclass and subclass in the implementation level. I believe you are familiar with this concept in Java programming already. About the deliverables of this lecture, there are two deliverables for structural modeling. The first deliverable is a conceptual definition of classes. You will have the documentations for identified classes with their responsibilities, including the defined attributes, operations, and their associations. The second deliverable is a set of class diagrams, including two major types of class diagrams, namely cooperative context and compositional context. You will have 3 to 5 different types of class diagram with different viewpoints. A class diagram must have a purpose. With the aforementioned objectives and the key points of this lecture, you need to further studies on readings and practice. You need to read lecture notes to achieve the required objectives in this lecture. You complete the quiz questions in order to get 2 marks of this week. The results of this lecture comes from Chapter 8 of the textbook. Lecture notes and review questions are available on LMS. Completing the task of each week is a key to succeed this subject. Please make sure to finish the learning activities each week. You may email your lecturer for consultations if you have any questions.